Hello friends, welcome to Civil Engineering exam. Today we are going to see the topic related with soil mechanics in the topic of water pressure. The topic particularly in the topic of effective stress, okay, effective pressure in the soil. So now we can take the effective stress is most important into find out the consolidation of the soil, shearing strength of the soil, then bearing capacity, then stability of slopes in the retaining wall, then lateral earth pressure on the retaining wall. So these things are most important to find out the effective stress of the soil. So now we know that three type of pressure in the soil. Okay, so there is a three type of pressure developed. So first one is total pressure, that is sigma. So then second one is pore water pressure, mu. Then third one is effective stress, sigma dash. Okay, so the total stress, we have the all the loads from the soil. We can take the surcharge, or we can take the soil self weight, or we can take the water pressure. So everything is come under this category. So that is the total pressure. So it is the total weight of the soil mass including the water present in the soil porous or water above the soil mass or per unit area. Okay, so now we know sigma equal to, that is stress equal to load by area. Okay, so that is weight divided by area. So now we can take the gamma, that is unit weight into volume. So weight is unit weight into volume, that because gamma equal to weight by volume. Okay, so now we have to find out the weight. So weight equal to gamma into volume. So that is the substituted over here. Okay, so weight equal to gamma into volume divided by area. So a volume we can write it as area into height. Okay, so now we can write as area into height. So the area and area will be cancelled. So now we got the value of gamma into h. Okay, so now sigma equal to gamma into h. So the gamma is unit weight of soil and the h is the thickness of the layer. So if case only one layer is there, so there is no problem. If case multiple layers are there, so the gamma value will be changed. Okay, so for example, take 2-3 layers. So first one is clay, second one is sand means. So the clay having the different unit weight and sand also having the different unit weight. So this is the gamma 1 and this is the gamma 2. So likewise we can calculate the gamma as well as h. Okay, so the thickness of clay layer is maybe taken as h1 and the thickness of sand layer may be taken as h2. So now we can take the total layers. So now we know gamma 1 into h1 again plus gamma 2 into h2. Okay, so likewise we can calculate the total pressure. Okay, so this gamma may be the dry unit weight or saturated unit weight or submerged unit weight, whatever may be. If case the water is present in the clay, so it will become a saturated unit weight. Okay, so if case the clay has some percentage of water content, we get the bulk unit weight. Okay, so if case the clay don't have the water content, so we can take in as a dry unit weight. Okay, so likewise we can calculate the total pressure. Okay, so here we write it as like that. So gamma equal to gamma dry into h1 and gamma bulk into h2 and gamma saturation into h3. So if case submerged unit weight, gamma submerged into h3 plus gamma w into h3. Okay, so we know gamma saturation equal to gamma submerged plus gamma W, or gamma submerged equal to gamma saturation minus gamma W. Okay, so likewise we can write over here. Okay, so second thing is pore water pressure. So the how much amount of water available in the soil porous. So due to this water the pressure will be occur. So that is called pore water pressure. So in the pore water pressure is also known as the neutral pressure. Okay, so it will be denoted as mu. Okay, so mu, or we can denote it as u, or we can denote it as uw. Okay, so whatever may be, we are denoting as a mu. Okay, so now we can call it as only the pond and river or lake. So we know two height of water table. Okay, so now we can take the hw1 and hw2. Okay, so for example, take this is a water table in the layer pond. So this we can take the pond. So here is the ground water table is there, and here is the water content is there. So here we can take the H1 and we can take the H2. Okay, so HW1 and HW2. Okay. And pore water pressure becomes a negative if case the capillary water from the upward from the soil. Okay, so for example, the capillary rise is above the water table, having the maximum value of topmost of the capillary rise. So now we can denote it as negative gamma W into Hc. Okay, so Hc will be height of the capillary water. Okay, so now Hc we found out Hc equal to 4 into gamma into cos theta divided by gamma into d porous. Okay, so next thing is effective pressure, that is sigma dash. So we cannot find out the effective stress directly, so we can calculate from the total pressure minus pore water pressure. So sigma dash equal to sigma minus mu. Okay, so sigma is total pressure minus pore water pressure. Okay. So next important thing is effective pressure or stress below the bed of river or pond or sea is independent variation of the water above the bed of the river. So it is independent of depth of water above the bed surface. So that's the most important thing we have to note here. Then effective pressure or stress in the soil must increase due to downward seepage. So if case the downward seepage is there, the increase the pressure will be, the effective stress will be increased. So there is no boiling condition, so there is no quicksand condition will be occur. Okay, if case the seepage is in the upward direction, so the effective stress will be becomes a 0, so the quicksand condition will be occur. Okay, so whenever the upward pressure will be high, so the effective pressure will be 0. Okay, so that is equal to total pressure is equal to the pore water pressure. So the soil will be tend to move upward. Okay, so like a liquid, so that is called quicksand condition. So we already know about the quicksand condition or boiling of sand. So this is a boiling of sand. So especially in the cohesion less soil and fine grained soil, so there is a chance of quicksand condition or boiling condition will occur whenever the effective stress effective pressure will be 0. Okay, here the effective pressure will be 0. So gamma submerged into H minus gamma W I gamma W into H equal to 0. So now pressure at the seepage equal to gamma W into del H, that is change in height. So now gamma W into del H divided by length of the seepage. Okay, so now we can take in as gamma W into, this is I into height of the soil. Okay. So now we can take the force seepage, that is pressure into area. So now we can, the pressure seepage is equal to I into W into H into area. So now H into A equal to, we know the volume. So volume come this side, though F seepage divided by volume equal to I into W. So now the J seepage per unit volume will be I into W is the answer. So next we have to know that the effective pressure increases in the capillary zone, where the capillary pressure negative, and hence now the effective pressure will be sigma minus pore water pressure. So that will be sigma plus pore water pressure. So we already discussed about that. So if case the capillary water, the pore water pressure will be negative. Okay, so now the effective stress, we know the effective stress equal to total stress minus pore water pressure. So here we can substitute minus pore water pressure. So sigma minus and minus of mu. So now we know the sigma plus mu. Okay, so this is the written over here. So due to rise in water table, the unit weight of soil becomes a submerged, gamma submerged, and hence the effective pressure will be decreased. So we know that why, because the unit weight of the soil becomes a submerged. So now the effective stress will be decreased. So then, due to lowering down of the water table in the summer areas, gamma submerged becomes the gamma bulk unit weight, because the submerged water level will be the bulk unit weight. So hence the effective pressure increases, which the main reason of consolidation of the subsoil during the summer season. Okay, so during the summer season the subsoil will be consolidated. So that's the main reason over here. So then, during the lower down of the water table, settlement of surrounding soil occurs when the developed downward drag. So the negative skin friction will be occur. So this is the in the pile foundation, the negative skin friction will be occur. So which result in the lowering down the uplift capacity of the pile foundation. Okay. So this is the main reason the pile foundation will be failed. Okay. So the increase in the effective pressure increasing the shearing strength. So of the soil, the bearing capacity of soil is shear stress equal to C dash plus sigma dash into tan phi. So for sandy soil, shear stress is directly proportional to the normal stress. These are all the things we have to notice and we have to learn about the effective stress. So we'll see the example problems in the another video. Again, we'll see next video. Thank you.